guys can all see this. Welcome to the CET Developer Conference online, the Inspector and Debug Graphics. My name's Connor Dudas. I'm an R&D developer at Configura, and I'll be giving kind of a rundown today of what the Inspector and Debug Graphics are, some developer tools. So first off, here's the outline of kind of what I'm going to be covering tonight. I'll be covering the inspector and the debug graphics separately. I'll show you how alt-click works, how to inspect from code, some of the new diff tools with it, and then in the graphics, some of the options that you have with it, and then creating your own, among other things. Let me double check on Zoom here to make sure you guys can all hear me. I think I can pull this up on the left. Okay, so what is the inspector? The inspector is a debug tool for developers. So this will have real-time fields and values in it. It'll show a class hierarchy, and we wanted to make it kind of like a web browser in the navigation field for it. So you can already see at the bottom here some of the tabs and the plus, and you can actually, how to access it. You can go to Emacs here, or CET, and you can hold Alt and click on an object. Now, if I click test cab here, it will open my current buffer in Emacs to the test cab class. But if I click the arrow, it will show the inspector. And so I'll go ahead and click that, and it pops open the inspector here. And so these are some values that are on my actual instance of the test cab. Like position down here, you can see that's at -0.5 and 0 basically. So that's kind of just the cool intro to the inspector. And then navigating through it, you can drag and drop different fields and values. So if I see that I have this vessel object down here, these sets of vessels, I can drag and drop that into a new tab. So I'll go ahead and do that. I grab this, and now I'm inspecting that vessels field on top of test cab. That's pretty neat, and you can close it, add a new tab, close that. And then also from here, I can right click on different things, open the class inside of Emacs. I can inspect that vessels thing in this tab, go back to the test cab, and sort of that kind of feel to it. And then within the inspector, there's a lot of information in there. And so we have these different display options that you have that drop down from this gear on the right. That includes values, boxed objects, null, class markers, methods, custom items, and sort collections. So I'll go back to my inspector here and show you some of those. So null, for example, I have all these fields that have null values to them. I don't really want to see that. I don't care. They don't hold much information to me at this point. So you can go ahead and turn those off. You can turn off values, which is any primitive that the class has. So I can turn off null and values. And already this is getting a lot shorter. So it can be easier to read. I can close the class markers if I wanted to, which is this prop object, core object, test cab, which I kind of like to leave on personally because you can minimize and open them. But, oops, you can actually go ahead and turn those off and get rid of them. And then also within the inspector, it is still a lot of information, even if you have those display options. So there is a search field in the upper right. And so you can search for things like position, or if you know you're looking for an int or even the name of your field, you can go ahead and search for those. It's just a little text-based search. And if there's multiple things, you can continue to hit enter and it will cycle through all of the ints that you have inside of your object. Inside of the inspector, we also have these helpers. So there's helper tabs that are up top, which includes function tab, a globals tab, and a recents tab. So I will go ahead and pull that up here. And so if I open this function tab, I have this text box. In here, I can run functions that return an object, and it will inspect that object. So I could put main space in here because it's a function from core. And if I ran that, it would inspect main space. I can also search for globals here based on type, name, and the package if I choose. So I'll go ahead and search for something that's of type color here, press enter. And now I can see some of these color globals. So G define colors, click that, pulls it up here, open these, and I can actually see the color that I'm looking at because these integer values don't really do me in. And these little color swatches are new as well, actually. They're a custom entry within the inspector. And so any color type will get this little tree node below it. And I'll show you later how to create your own nodes within the inspector. And then also within the inspector, you'll notice that we have these 2 rows of buttons at the top. The first row of buttons is always going to be there. So these are the standard buttons that you get with any object that you inspect. You have adjust filter and filter, which adjust filter will kind of put you into a state where you can choose to what objects that you want to see. And then when you apply the filter, which is when you click filter. We have update on snapper selection, which will always inspect the currently selected object in space. We have a picker where you can click it and then go out and choose an object to inspect. And then we have record and diff records of this, which will save the test cab at a certain state if you hit record. And then diff records of this will go into the past. And anytime you hit record on that specific instance, it will show you the difference between all of those records that you have. The other row of buttons we have down here are class buttons is what I like to call them. And so these are buttons that are associated with different classes. Show prop defs is associated with prop objs because they have defs on top of them. Show connectors, show mesh, show center, those kinds of buttons are associated with snappers because snappers are the only objects that actually implement those. And so if I am inside here, I can click picker, go out into space, select my test cab, and now you can see that I actually have that second row of buttons. So I could click something like show connectors, and there you go. I can see my connectors. Show prop defs will pop out the prop defs for that specific object. So if I wanted to inspect my scarecrow using the picker and show his prop defs, he doesn't have many, but I can kind of compare those prop defs side by side. So those are the buttons that are also within the inspector. Recording within the inspector, so that's something that I kind of briefed over, is you can click that record button. So we'll go in here. I'll give you a play-by-play. We have my scarecrow. I'll actually go back to the test cab here using my navigation arrows. I will hit record, and then to find that record, I'll go to recent, and you can see that I have that saved object here. So I can actually open that up, and this is just going to be that same information that we were just looking at. But if the test cab ever changes, like it just did now, I moved the position of it. So you can see the position of my saved test cab is -1/2, 0. And if I go to the real test cab by selecting it from recent inspections, you can see the position is -2, -2, and 2.5 at the current position. It can be kind of hard though to see those different fields there. And so we made a diff within the inspector to kind of show you the differences between your recorded objects, the live objects, or different recorded objects even. And so what you want to do is when you're inside the inspector, you can select which objects you'd like to diff. So I want to diff my current test cab and the saved version of it. And then I'll diff selected. And here it'll highlight all the differences that I have between the two. So position's really the one that I'm looking for. G instance, this underscore graph also has a difference, and the holder has a difference inside of that. I believe the holder's probably like something like selection from space. Yeah, last selection. But these scroll together, so that's pretty nice, but it becomes a lot of information to look through. And so we actually have this little show differences only, which makes this a whole lot easier to look through. And so that's the new diff dialog. You can diff as many objects as you want, as you can imagine. It'll get lengthy, but you can always grow and shrink it, stretchable. And then finally, these are developer tools, so we wanted the developers to be able to access them from within code. So to inspect an object, you have to be using core, which I'm assuming you are for the most part, but if not, you have to be using it. And so vessel v I created, and then all I have to do is call inspect on v, and that will pop up the inspect dialog from within CET and show me all those values that I was showing you earlier. To record from within code, you want vessel v, and then you can inspect record of v. I like to inspect record using these tags here to group my objects together. So I could inspect record with just one thing, which is just pound vessel, or I could inspect record with multiple tags, which is vessel because v is a vessel, and from t because it came from my t file, just a tag that I came up with. So then obviously, since you can record these things and inspect things within code, we have a diffing from code. So this is a more lengthy example here, where we have a vessel v, I record it, a vessel w, I record it, and you can see I have these different tags on it. Both of the vessels have the vessel tag, and I also put important on my first vessel v. I also created a snapper a and inspect record a, and this one's a snapper, so it's getting the snapper tag and important. And then I can diff, and I'm choosing to diff based on the important tag. So I'll actually be diffing my vessel v and my snapper a. And you can see that I have these two optionals here, clear equals true and replace equals true. Clear means that I'm going to clear the backlog of records. So I'll have no records after I run this. Just so if I'm running a lot of diffs over and over again, that I no longer have this huge saved records of a bunch of V's and a bunch of A's here. And then replace equals true. If you have a diff window open, because you've been diffing a lot, replace is nice because it will just take that window, it'll toss it away, and then you'll get a new window right in place of it. So there's the optionals there. So I'll open CET and I will open my Emacs here, where I actually have this example loaded up already. So if true, and this is the exact same code that I was just showing you. Vessel v, vessel w, snapper a, inspect if on important. So I'll go ahead and run that. And you can see that I get this diff dialog popped up. You'll also notice that there's not a lot of information that it's diffing here. That's because I'm diffing a snapper and a vessel. So if I'm diffing two different objects, we'll try to go to the ancestor that's most common between the two. And it'll display that in the diff dialog. So vessel as core object and then snapper as core object. And the only difference, it turns out, is the defs. The vessel has its defs and the snapper does not have any defs on it yet. So that's pretty cool that you can do that within code. It's most useful if you're doing it in a loop or at a specific state in an animation, are some things that I really like to run those at. Another thing that I actually didn't include inside the slideshow, because I forgot, is that you can inspect an animation now if you're a developer running in dev mode. So if I have this remover up and I'm curious what animation is, I obviously can't alt click on the animation because there's not really anything to click on. So what we implemented is that you can alt I, which will pop open the inspector on that animation. So I can actually see now that that was a toolbar generic remover animation G2. And if I want to see it in Emacs, right click, select it, and bam, I go right to the class in Emacs for that animation. So that's kind of a tool that I can find very useful sometimes, especially if I'm finding bugs within an animation, but I have no idea what it could possibly be. So we'll go ahead and close that. Go back to our slideshow here. And then here's those custom items that I was talking to you about, like the color swatch. So to create a custom item, you will need to create a viewer object. This is just a fancy tree view item. And I've made my own right here. I called it condu.vo, Connor Dudas, that's my developer tag. So it's nothing special. And then the real magic happens at the draw text line here. So I have a constructor, this.font equals system font, just to grab a font for when I am drawing my text. And then when I draw it, I have access to this value. A tree view object has a value associated with it for us. And then you're gonna want to do what I chose to do, actually. You can do anything you want in here between begin paint and end paint. Go wild. You can draw a color swatch if you want. But I just chose to draw the class name at the clip rect position 0. So I actually have this loaded up in code as well. So this is that same object that I was just showing you. Condu viewer object, this dot font, and then here's that special line. Not that special. You just take the value, class, toString, underdrawing the text. You can draw whatever you want between the paints. You're also going to need to register your viewer object now that you have one. And so to do that, you're going to grab the inspector viewer manager, IV manager. I'm going to put snapper and condu viewer object, an instance of that. So the snapper class is actually going to be like what my object is associated with. So anytime you inspect a snapper now, my condu viewer object will be associated with it, which will just draw text. So we'll go ahead and make this true. Compile it, run it. So that was enough right there. Just this viewer object, I ran it, I put it in the manager. So if we go over to CET now, and I inspect the scarecrow, you can see that I have this new entry here, scarecrow, just the class name. If I went to recent and I pulled up my test cab, you can see that I have this test cab entry. If I go to the remover animation, I don't have that because it's not a snapper. So any snapper is going to get this tree view entry that I have under it. And this is my custom one. You can tell because if I turn off custom items, it actually removes that. This table here is also a custom item. It involves a little more work, but you could create something very similar to this prop def table that we have here. And so this prop def table is actually new as well, and one of my favorite new features of the inspector. So in here, it shows a list of your defs. It'll have the def key, the type, field name, value, if it has a prop setting or not. And so it just kind of shows that information just kind of more in your face, so you don't have to go through and dig through this map. Is there someone there? I think I...
Sorry, I clicked something. That's probably me.
Oh,
but I do have a question.
Yeah.
So you're saying that this viewer object is basically just a tree view item?
Yep.
Does that mean you can append children to it?
You cannot append children to it. That's a good question. I haven't tried actually thinking about it. You definitely should maybe be able to indeterminate.
Maybe. Okay.
Yeah. So that's not really something that I actually looked into, but that's a good question. I think you should be able to.
Basically, you would just need a hook for like, we're about to render this with this object. And then you could like add and remove nodes after that, right?
Yeah, for sure.
Is there such a hook, like we're about to render or something like that? Do you know?
Maybe within the object. I'll Alt-I on it here. Actually, you definitely can, because I believe we have one that's called neighbors. So if I create another scarecrow here, and I choose to inspect the scarecrow now, I have this neighbors tab, which has sub items within inside of it. So you definitely can create items within your own tree view item. Do I know off the top of my head how this got implemented? Definitely not.
But it's there.
But it's there.
Sweet.
So there's definitely a way. It'd just take a little bit more poking in code to do that sort of thing. And this is actually a good time to ask a question because that's kind of the overview of inspector that I have. So are there any more questions that have to do with the inspector or custom items and registering them with the inspector? Nice. Sounds like I covered it all. How does he do it? First try, except for one thing. Guess I did have a question. Shoot. So with that, I'll have another time for questions at the end if something pops into your head. But I'll be moving on to the debug graphics toolbar and debug graphics in general. So first off, what are the debug graphics? These are things that will help you debug, and they'll give context to a normally non-visible attribute in space. So you can see even just in this little picture that my table down here has weird kind of connectors surrounding it. I have actual connectors turned on. So that's actually connect lines and a connect face, which I'll kind of show you in CET as well. But first of all, how to find that toolbar, this slick new toolbar, is you have three ways you can do it. You can do it inside the debug menu, which is at the top left, click debug, debug graphics toolbar, and that'll pop it up. You can do it from the monitor toolbox tab. So you go there, click debug graphics toolbar. Lo and behold, it'll show debug graphics toolbar. And then you can also do it from code by using this show graphics toolbars function. And then you can remove it in code by saying remove graphics toolbars. The debug graphics toolbar options from the debug menu and the monitor toolbox toggle the graphics toolbar on and off. And so we have a handful of debug graphics options that are already preloaded for you. So I'll go ahead and go to the monitor toolbox, debug graphics toolbar, pull that bad boy up. So here's some of the default graphics that you have. We have the BSP. We probably don't have enough snappers in there to make it interesting, but as you get more snappers, you can actually see the divisions between the individual nodes in the BSP. And there's a snapper BSP, a vessel BSP, and a singularity BSP. So that's the binary space partitioning that helps you click and find snappers faster if there's a lot of objects. We have stuff like hidden lines that shows you the outside of objects, all the hidden lines that go along with it. Gives it a little bit of a cartoony feel. Bounds is one that I find pretty useful. If you're trying to click your object in space and for some reason you just can't while creating it, you can turn on the snap BSP bounds. So this is what the BSP actually sees for the bound of your snapper. And then you can actually have the local bound as well. And this is the local bound that your snapper has. So you can see that the snapper local bound has a rotation to it, but the BSP bound never has a rotation to it. And then one of the coolest features that I think that we added was this connectors tab here. So we have visual connectors, which isn't all that exciting because it's the visual connectors that you can see. But then we have the actual connectors, which is a whole lot more exciting to me because you can see that I have these connect lines down here and the connect face. So it'll give me a more detailed outline of what's happening with the connectors, especially if it's a line or a connect face. If you're getting some funky behavior and you're like, why is my plant snapping at a weird angle? Go ahead and turn this on. Make sure that your connect faces has the right orientation. And then we also have offset for connectors. So I went ahead and added an offset to the test cap here. So you can see that when I go to attach these bad boys, that they're offset from each other. That's because they both have offset connectors. Another cool portion to this is that you can click and select the connectors here. So if I open Emax. I'm going to shove this over just slightly. Here we go. Oop. And now when I select this connect face, I can actually see that it's in the offset connector pos belonging to this snapper, this connector, this is my position, and this is my rotation. I have 0 connections. So on this table, I can add these little storage units. And now I can see that I actually have these connections here. And so when I click on the connect line for this front table, it'll highlight and it'll say, this is the snapper, this is the connector, the position, the rotation, and then both connections to it. So I can see that it's connected to this line with this rule, and then it's the Fika office pedestal snapper that's connected to with this ID. So that can kind of help you show like what's actually happening when I'm snapping these and connecting them. So that's just another cool thing. And there's some more tools in here like normals. That's just some graphics thing. Meshes takes you back in time, but it just shows you the triangle. So it kind of gives you a visual representation of how expensive this object is actually going to be to render. We also have things that ID CMSim or like the axis helper. So if I go ahead and delete these, I can actually see the 0 point for my snappers and kind of the orientation. So what's kind of weird is this Fika Office work surface. The 0 point is in the upper left corner for it, whereas in the test cab, the 0 point's down here. And I can click those and it will show me the position and rotation just to give me some rough feedback. And so back to the slideshow after showing you all of those. I'm sure you're interested in creating your own debug graphics vessel. And we tried to make it relatively easy without taking away a lot of the functionality. And so to start making your own debugs graphics vessels, you're going to, one, extend debug graphics vessel. I created one called condu debug vessel. You're given a core object C, which you can see inside this get2d. I'm casting it into a snapper. And what you need to do is create graphics that are actually going to display. And so inside my get2d, I cast C to a snapper, and I just create a little circle at the center point of my bound. And then inside of get3d, oops, scrolling, force a habit, I have C as a snapper, and I have a sphere 3D that I create at the center, and then just return that. And so that's all I have inside of one of these debugs graphics vessels. And so I have my condu debug vessel, and then I need to register that vessel with the manager basically. So to do this, I'm going to have 3 steps. One, I'm going to need to create a callback for this vessel. So that means when you click those buttons, they'll either turn on and off, and they'll apply to a set of objects, which is usually all of space. So you can see that you're going to need a vessel class, which I have at the bottom here is condu debug vessel, the object I just created, and then a unique symbol group. That way the manager knows how to clean up, get rid of, and destroy these vessels when that item is turned on and off. So my unique symbol group is just pound Connor. I'm very creative with all my names, as you can see, condu, Connor. And then we actually have two helper functions for you, because it can kind of be heinous to add and remove those vessels all on your own. And so we have toggle debugs graphics vessels on snappers. So it's a mouthful, very verbose, but very specific for what it does. And so what that does is it will toggle the debug graphics vessels, which we set as condu debug vessels on snappers. So this is only going to be a graphics vessel that is registered to snappers. We have another vessel or another function that is toggle debug graphics vessels on vessels. And so that will give you debug graphics. Your vessel will apply to other vessels. in space. So that's just my little helper function that I'm going to call, but I'm going to call my actual function toggle condo. Just has the signature with a bool v, which is for on or off, and then the objects that's going to apply to. So that's the first step, is creating a callback. It's a mouthful, but it is really easy in the end. And then you're going to need to register with the manager. And so to register with the manager, you create an object, which is going to be debug graphics. I usually like to make a global for it, just because then I can call debug underscore condo dot enable or dot disable. So I can call that from code, or I can click in the toolbar. So this debug graphics, you're going to choose a key, which I chose as condo debug. I gave it my function, which I call toggle condo. On by default is false, and most of these are going to be false by default, just by nature of them being debug graphics. And then the manager is debug underscore graphics. And so when you create this debugs graphics object, it's going to register it automatically with the manager and add itself to the toolbar with the little name condo debug. If you want to modify the toolbar item, you're going to want to create a graphics toolbar env. And when you create this graphics toolbar env, you're going to use the same key that you registered your debug graphics with. So mine was condo debug, and then provide some props to go along with it. And so you have some options. I'm just choosing to change the display text to condo graphics. You can have a symbol group, which is kind of like how that bounds has, or the BSP, where it gets that drop down. And so it'll be called from that symbol group. And then when you click the symbol group, your item will be inside of there. You can have a text offset and an image offset, which is that little black square. And the text offset is just your text, which is condo graphics for me. So I'll go ahead and pull this up. And yeah, I can turn this off still. Graphics toolbar, it's off. And then here. So this is that same code that I was just showing you, just a little more condensed since my Emacs is small. So I'll go ahead and set this to true and compile it. But also something small that I added to my debug vessel was actually this local bound, which makes it clickable and then selected. So I'll print the object PLNC in selected, and that's kind of how I'm getting these test cabs down here, right? And seeing the position. So when you see my object, you're going to see just the object #C. So I'll go ahead and run this. So I am creating my object, creating the env. So I have different graphics on the toolbar, and then I just showed the toolbars there. And so now you can see at the end here, I have condo graphics. Handy that. Who would have saw that coming? And so when I turn that on, it turns on those vessels. And since I implemented a local bound and selected, when I click on the object there, which is the sphere, it prints out C equals test cab. I click here, it prints out C equals Fika office straight front work surface. So hopefully it's not that hard to implement. That's the dream, to add your own graphics if you want. You can toggle them on and off just like the rest of the graphics. And if you hide your toolbars and you show them again, once they're registered, they're always going to be there. And so I always have this condo graphics item. And that group that I was telling you about, the symbol group, is actually like this BSP bounds and connectors. So the way that the bounds are registered, when I create the env, I just have group equals pound and then bounds. And then all 4 of these items get into that group. So if you find yourself that you have like a specific group that you want your graphics to all be attached to, then they can all be registered inside of a dropdown like this. And so that's kind of how to register your own debug graphics. And with that, that actually wraps it up. It's not the biggest thing in the world. It's not the hardest thing in the world. But does anyone have questions about it? Because I know it can be a little bit confusing when you first start, especially with the inspector too.
Not getting anything.
Yeah, no questions. Once again, I covered it all. I don't know how I do
It's
it.
feature complete. There's nothing to discuss.
Yeah. So I guess if you guys have no questions, I can stop sharing my screen here, which will take me back to this. And that's all I have for you with the inspector and debug graphics toolbar. As always, if you come up with questions later, reach out to Configure. We have developer support, stuff like that. Yeah, but I hope you got something from it. And go ahead, try implementing your own objects inside of the graphics or the tree view if you want.